Today I'm going to go look at this 10-piece wrench set as a single file with 10 configurations. Some of the ins and outs of this. I am going to stick to this basic lettering scheme, so I might have to reference that a few times to remember it. But that way our two wrenches are laid out similar, even though the 10 over here doesn't have this table. And you see in this one, that's the center of the hex, the center of this radius, and it works out to the center of these radii as well. The one here that shows, which appears to be setting a chamfer, the amount that's left flat. So we'll have a calculated number here for a chamfer that we're going to keep. And then there's I'm taking it to be an outer radius here, concentric with this one that we are not seeing. If we have this line set here, the endpoint of this arc is on it at the endpoint, and its value is known, and this width is known about this center, this is over defining it. So I'm not going to address this. This would have been the A value. I'm going to leave this undefined and define it by this radius. And then because it uses that radius and these to figure out our chamfer. So I'm just going to let the system solve for this because we're over constrained. This tangent point of this arc is going to vary from wrench to wrench, whether it falls tangent to the outer or the middle radius. So I'm going to leave that out of our sketch, but we do need to mock one up to get this point right here where we're taking a thickness and a width. This end also has a thickness and a width. There's a radius here that's not defined and radiuses in the corner that are not defined. Well, what I found is working good for me is to use this radius as a value of twice this and then go with a constant corner radius of 1/8 inch in all locations. So there we go. I'm going to try to stick to my order on my dimensions that we saw here. The width of the hex being WA being omitted, and then B on down, length comes later. I just like the idea of keeping my format the same. So I'm going to drag this over and we're not going to look at it no more. I'll get numbers from it, but we're going to start a new part here in inches in SolidWorks. Top, sketch. One thing I'm going to do from the get-go is do a couple center lines. I'm going to try and hold off on my dimensions. This 15 I'm going to enter because it's going to be a constant and we're not going to adjust it. There's going to be a hex in here. I'm going to put along that line. So it's tipped at 15 degrees and I'm going to make it reference dimensions. There's our first value, is that W. I've got a max min of 2.23 and min of 2.224. It's a spread of 6/1000ths. So adding 3/1000ths to the 2.224 gives me 2.227. We're going to have a line right here, a line right there, and a arc that I'm going to put on our center. remember we're skipping A, and this is our B dimension, which is 1.309. There's a C dimension, which is this value, 0.998. And this value is done in halves, and it's 557. Alrighty, that's our D. Our E ends up being this arc here. And then F is an arc right here. E, F, G, and right here. These two being concentric, and these two being concentric. For some reason that one didn't take. There we go. And those are going to want to be reference lines. So our E is 1.775. I didn't set this point to there. The center line is defined by this, or the center point rather. There we go. These two need to be equal. And I'm going to make this tangent at both these points. So our F is 1.68. And our G is 2.823. I'm going to go ahead and make this 4 units, because if we don't, it gets rounded off. Actually rounded off and changes the number when we go over to equations. Alright, so that's EFG. H is a corner radius, which in this case is 0.275, which is found here and here. Okay, I'm going to skip our J. Our J is a thickness dimension. And I'm going to, now some people would do a different solid on a different part. You don't always have to. I'm going to do 2 solids in this part, or rather 2 extrusions from this sketch, I should say. So bear with me a minute here while I get this piece set up, and then I'll explain what's going on. And we're going to need to have a line center right here. This is what we're going to actually be dimensioning. I'm going to make this tangent. Now there is a radius here and a radius here that, for reasons I already mentioned, I can't define here, or I won't define here. But this one is useful for determining where we're taking this thickness and this width dimension. So I'm going to use it. And that's our, let me see what our K value is. I'm not remembering. It's been a few days. This is our K value. And I'm going to call this one K1 in the end, and K2 because we've got 1 at each end. So K1 is 1.664. And K2 is going to be this one, 1.465. This line is coincident with that sharp, theoretical sharp right there. And that's our K. And then comes length, which in this case is 1'6" or 18 inches. Yeah, that's not playing nice. Okay. One thing to help with this is I'm going to go ahead and define this now. Remember, it was 1.465 times 2. It's going to be a calculated number. So it's not going to mess up our scheme much to just throw it in here, because we're not going to pull it over to the table. Okay, I'm going to tie that in later. It's causing me problems. So J and N are thicknesses. We're going to have an N1 and an N2. So we're going to skip those. So that next thing up on our chart then is Q and R. And Q is this upper one. I'm not going to define R yet. And this is 3.992. And I'm going to just make it tangent to this one right here. Like I say, this line is sometimes going to fall tangent here, sometimes it's going to fall tangent there, so we can't include it in the sketch. Now we're defined, and we can... I see what happened. We tied to the wrong end of that arc. Now we're right. And there was a value down here. I was going to go with 0.125. Okay, that's more than enough to deal with right now. I'm going to go ahead and set this in my equation, all these values. I'm going to call this fixed 1. It's not moving and we don't care about it. This was W. Now see, if this was 2 decimal places, if we hadn't changed it to 4, it would actually make this 2.23 right now, and it would be 2.23. It would not be rounded off. It would change it to that value. That's why I did 4, so that we can maintain these values out to the 4 places. Really, it could have been 3 in this case. The other wrenches, it has 4, because you get a 4th digit, a 4th decimal place when you take the median of the hex size, the W, but we could have got by with 3 here. Now that I'm looking at it and thinking about it. And then the 1.39 was our B, C, D, E, F, G, H. J is a thickness we haven't done yet. K1 is 1.664. K2 is 1.465. L is the length. And if you remember, this is the end radius that we set. I'm not going to change it. It's going to be set from K2 times 2. And this is our Q. And this is just fixed too. I'm going to call this equation 1, so it's equation driven. So everything has a name. Not a big deal. So I'm going to go into the sketch and I'm going to extrude out our J value, which is the thickness of this. I'm going to do it as a mid-plane, and it's 0.892. The next number that we had was actually, I'm going to go with our N2. We're going to change that over in the spreadsheet, or the equations. 0.531. We're going to get to 598 by way of a taper that we're going to have to calculate. I'm going to go ahead and make this display, and I'm going to set up a plane right here, perpendicular to the center line at this point, to use for our reference for our angle. But then I'm going to sketch in the, I want to reverse this so that we don't have to reverse our angle later. And I'm going to sketch in the front view. Here's our N1 value, which is 598. I'm going to put the midpoint of that piercing that line. So that sets up where that dimension's taken. I'm going to throw in an angle here. This is going to be a calculated draft. It was 0.15. I'm just going to use that for now, but we're going to use this draft angle, these two faces, and 0.15. This is going to be our Q, which is 3.992. We're going to tie it to it. Look how close it comes to that tangent line. And then R is this lower one, 1.394. There's the decimal, there we go. Okay, let's throw on a chamfer. We'll change it later to be our calculated value. And I'm going to actually use a radius here of the same value. Right now I'm just using 0.5 as a stand-in. We'll make it the real one later. And that's just a design decision there. So now we've got everything in here that we're going to need. Let's go finish out our equations. 0.892 was our J. .531 was actually our N2. The next one was our N1. Same dimension, different location. This is our calculated number, and we've used I see one thing I got to go back and add. Is going to be our second calculation. And this is going to be equal to that calculation. So I'm going to say EQ1. It's equation driven. This is EQ2 equation driven, and it is equal to this Q. And which case this is our R. And this goes back to that calculated number that we don't have here. Go back to our first sketch. I forgot to throw this guy in here when I was done. That's going to be for our chamfer calculation. Go back over to our equations. These should be added up here somewhere. Right there. And that's our first calculated number that we didn't do, and he's going to be what we're using here. This is EQ3. This one doesn't change ever, fixed 3, I believe. And that's EQ4 and EQ5, which I'm going to make the same as Calc 1. And again, Calc 1. There we go. Now we're all set. So if you remember, we go up here and insert design table. Tables. Design table. I'm going to do auto create so I can pick my values. We're ignoring fixed and equation and calculated numbers. Q, J, our N's, and our R. I believe that's all we need. That's a lot. And there we go. There's our table. I'm going to put them in order. Insert cut cells. K, L, elemental P. I'm actually going to do N1 first. It doesn't matter which one we cut and move. One of them needs a shift. There we are, in order. And this default is our 1 3/8 key. If you remember, we can't use the slash in here. So we got a 1 3/8, 1 1/2, 1 5/8, 1 3/4, 1 7/8. 2, let me make this table a little bit bigger. 2 1/8, 2 1/4, 2 1/2, 2 3/4. And then I'm going to go through all these numbers. I'll probably edit this and skip ahead, but let's go through number 2 together. Our W in this case is 2.24 to 2.414. Okay, on this one right here I found an error. And if you look at the format of the ones above and below it, you realize they've transposed the 4 and the 2. So it should be 2.42, just like this is 2.23. 1 in the seconds place higher from the min, so that there's a spread of 6,000. So 6,000 of that should be 42, 2.42. So they've transposed those two numbers, no big deal. All right, so I got it all filled out, created all those things. Now let's just step through them and make sure they all work. There's an error there. It was our 2. Edit, design table, edit table. Two inch is 6 right here. So let's step through it. 3.157, 1.869, 1.435, 0.789, 2.559, 2.42, right there. 2.425 for, what is that? That's G. 0.062, 0.4, 1.246 is our thickness. Okay, 2.357 and 2.076 and 26 is our length. 1.847, 2.752, 5.657, 7, and 1.9. Okay, that should work. There we go.